Welcome you all to the Research Spark YouTube channel. So this is the second part of the unit 4, that is the line theory and introduction to interference. So here's the syllabus and the content. So in this session actually we are going to talk about the EMI, EMC, then the types of EMI, EMC, SCE, CE, then susceptibility. So let's talk about the EMI and EMC. Actually, what do you mean by the EMI? So electromagnetic interference, that is EMI stands for, refers to the unwanted disturbance that affects an electrical or electronic circuits due to the electromagnetic radiation emitted from an external source. External source may be the your any electronics gadgets. As for example, your mobile phone is also a source of electromagnetic radiation. So this interference can degrade circuit performance, cause data errors, or even lead to the device malfunction. So this is important to reduce the interference. Otherwise, what will happen? Because of the electromagnetic interference, the performance of your device will reduce. Then the electromagnetic compatibility. So it is the ability of an electron devices or system to operate properly in its electromagnetic environment without causing or suffering from EMI. So this will give you the the buffer zone where your device can work even if some electromagnetic interference radiations are there. So then the types of the EMI, so maybe the conducted, maybe the radiated, so electrostatic discharge. So interference is transmitted through physical conductors such as power lines or cables, common in switching power supplies and motor drivers. And the radiated means interference is emitted as electromagnetic waves through space. So basically the place, and then the types of EMC. So emission, that is refers to the unwanted electromagnetic energy emitted by a device. So mainly it can be categorized in two parts, that is SE and CE. Emission, that is unintentional radiation from circuit, and C, that is conducted emission, that is interference conducted through power signal cables. Then susceptibility, that is immunity, the tendency of a device to malfunction when exposed to external electromagnetic disturbance. So how much your device can malfunction, that is a susceptibility. Highly immune system continues to function correctly even in the presence of EMI. So please go through all these details by yourself. These are the very easy topics, just you can study by yourself. So here are some key highlights about EMI and EMC. So EMI causes the disturbance. This is nothing, basically the electromagnetic disturbance. So like it's a traffic, like if I'm considering the example of your road traffic, then if some vehicle is passing, then definitely if others vehicles are also there, then because of huge traffic you cannot travel, right? So here also this is the electromagnetic wave traffic, it is there. So these are the things. So please go through that. Then before going to discuss the fifth unit, these are some key points that you should cover. So these things are not in syllabus, but still this is the very important topics, that is VSWR, that is voltage standing wave ratio. So Z dot, that is Z in, will be the Z naught into the ZL plus ZO 10 gamma L, and Z naught plus ZL of 10H gamma L. Gamma is a propagation constant for lossy medium, and then for lossless medium your input impedance will be written like just replace the value of the 10H gamma L. Alpha, it is alpha will be 0 for lossless medium. So in that case you can replace. Further, the tau, that is reflection coefficient, can be calculated as ZL minus Z2 divided by ZL plus Z2. And S, that is S matrix, that is SWR, standing wave ratio, can be calculated as by ratio of V max by V min or I max by I min. And also it can be calculated is equal to 1 plus tau L divided by 1 minus tau L. For different cases like sorted lines, if ZL is equal to 0, so all these are for transmission line only. ZL, suppose the length of transmission line is 0, then what will be the value of Zin? So Zin will be J Z naught 10 beta L, and so this is for your sorted line JZ. So in that case tau L will be -1. How tau L will be -1? Just put the values of ZL ZO here, because Zin is equal to for this ZL is equal to 0. Just put the values, you will get tau. Similarly, in order to find the S, just first find out the tau, then put the values of tau here, and you will get the value of S. For open circuited, ZL will be the infinity, because transmission line length will be the very large, that is infinity. So in that case, put the ZL is equal to infinity here, and then get the value of ZL is tau L is equal to this. Why? Because you can neglect the ZO. It's very high. So get the value of Z naught, Z in tau L and S. Similarly for matched line, Zn for matched line, ZL and ZLO both are equal. In that case, tau L simply will be the 0 and S will be 1. So these are the some requirements. So please go through these details. These are the very important, the topics which you should understand before going to ahead. So 5 minutes we are going to cover the Smith chart. Thank you for listening. If you have any problem, you may drop your comments. Thank you.